Current technology causes a multitude of problems such as overheating and excess power consumption. It's consuming 20% of our world's electric power. So, what's the solution? Do you think it's time to move over our current technology?
Before I answer, let me ask you a puzzle. Can you think of an insulator that also conducts with no energy loss? Puzzling, right?
The answer is topological insulators. Topological insulators conduct electricity at their edges but insulate in their bulk.
Their conducting edges are topologically protected as they are immune to changes such as stretching, bending, or twisting. Their existence is a breakthrough that will impact spintronics, quantum computing, optoelectronics, and fundamental research.
Charles Kane and Eugene Mail received the Breakthrough Prize for their research on the same in 2019. So how does this work? Band theory can be used to explain the behavior of conductors, insulators, and everything in between. A material's ability to conduct depends on its electron's ability to jump between energy bands. In conductors, the band gap is small enough for electrons to move across. In insulators, the band gap is too big. Now, in a topological insulator, the electrons are in cyclotron orbits due to the Lorentz force experienced by the electrons due to their charge and an intrinsic magnetic field. Electrons are stuck in their orbitals due to the Lorentz force, forming large band gaps. At the edges, these orbits cannot be completed since they bounce off the edge, causing them to skip orbitals and form a gapless topological edge state. The electrons in a topological insulator display spin-orbit coupling, which is the interplay between an object's spin and its orbit. An example of this could be a spinning top. This results in spin momentum locking such that electrons with opposite spin will also move in opposite directions. Since electrons can only either spin up or spin down, they can only move in two possible directions, forming a two-way street, where electrons can't break from their line. Since electrons are so well behaved, they never collide, therefore the conducting edges of topological insulators have very low resistance. Hence, there is negligible energy loss, making topological insulators so much more efficient than their predecessors.